In lecture 15, other type of organic photochemical reactions are introduced, and mostly on the reactions of the carbonyl molecules. So let's remind you that at first what's special for carbonyl molecules, and let's think about the structure or electron configuration of the carbonyl molecule. For example, here, and as we studied carbonyl molecules, we have pi, pg orbitals makes a pi bond, and also the importance is we have some non-bonding orbital. So in the oxygen side, py, non-bonding orbital, and also there's another two non-bonding orbitals, right, in the oxygen side, and one of them is from the sp orbital and one of them is py orbital. So not only the pi star state, but also we have to think about the two non-bonding orbital in the oxygen side, which is occupied by the electron of oxygen, and pi is oxygen. So this is the electron configuration of this. So what happened, especially for the n-pi star excitation, right, is the electron distribution quite changed because one of the electron in here is coming to the pi star state, which is extended into the CO bond. So the double bond is getting weaker, and CO is becoming radical-like species. That makes the activity of carbonyl much higher. And as we studied, this n-pi star excited state has two typical reactions called Norrish type 1 and type 2 reactions. And one of them is the alpha cleavage reaction, which is if we have carbonyl, and this carbonyl is connected with other carbons, and since this one is more radical-like species, it could cut off this sigma bond. This is the first type of reaction. And also, the other type of reaction is hydrogen abstraction reaction when it is excited. So this could happen like when it is excited, hydrogen is taken, and then due to the excitation, the one of the oxygen side electron is excited, and then this bond is like this. So what you can obtain as an intermediate species like R or H radical species, and this is going to be more logical, right? and apply like this. And then, since this is more like radical-like, so this part can't to generate in this specific case, it could give the OH like this one, and then this type of molecule. So that's, but anyway, the key point is, as I mentioned, that this hydrogen abstraction reaction. So let's take some of the example I've already mentioned. One of the examples. Let's see. The first, the hydrogen abstraction reaction, and which is actually already shown before. It's a benzophenone. Benzophenone is excited to singlet excited state and changed into almost 100% triplet state. And this triplet state is going to react with the other molecules to give a radical-like species by hydrogen abstraction, and you could obtain the radical species, and that's make dimerized to give this molecule. And here the alpha cleavage reaction, example of alpha cleavage reaction. So as we mentioned, so that if it's a symmetrical molecules, the possibility of the cutting is here and there. So what you could obtain is CO plus radical species, for example. And then it's possible to generate, like, for example, I'll explain or this logical coupled again to make a button like this. So that's and this kind of alpha cleavage reaction has been utilized for very frequently for using the initiator reaction or for polymerization reactions.